Can we see everything? We can. Go ahead, Elaine. Yeah.
It's really pretty different, and I mean, for me, I'm fine, but...
Pretty straightforward, yes?
Yeah. The only thing in E3, my numbers are a little bit different.
Not a problem. Not a problem.
Like, instead of 103, I got 104. Probably because
It's probably a rounding issue.
That's
Don't worry about it.
Yeah,
Please do not worry about that kind of stuff in this class. And I know that's hard for you guys to kind of deal with. Coming from algebra classes, most of you came from probably Math 111 or some other algebra class into here. I'm not going to wrap knuckles if you're off by a number or two. I mean, it isn't the point. Now, if you have a simple data set like on your last in-class exam, and I say find the average of these numbers, I try to avoid that by saying, is your average less than, greater than, or equal to, blah, blah, blah. That's about as exact as we're going to get. But for something like that, I'm not worried about that.
Yeah, and the reason why I had so many questions in the previous one, because actually the previous homework was based on the book material. So I had to go...
Hopefully we got them squared away.
Yeah.
Good.
So, and thank you.
Oh, you're welcome. You're welcome. You're welcome. You're welcome. Anything else give you guys grief down here? I had to revisit margin of error one more time. Had to. Just had to. Because it's one of those things for you guys not taking 244 to let you come out of this class without an understanding of margin error is just awful. So that's why your last quiz from last week also included that too. I think it was good seeing it again. So, make sense? Yeah, pretty straightforward. Television viewing linked to increased risk of type 2 diabetes. I love this study. I'll mention one homework question from this. So prolonged television viewing linked to increased risk of type 2 diabetes. Perfect. I got no problem with that statement. The problem I have with the statement is down here, somewhere, boom. The message is simple. Now this is by the senior author of the study, who ostensibly understands statistics. Cutting back on TV watching can significantly reduce risk of type 2 diabetes, heart disease, and premature. What amazes me about this statement is the person that did the study, and the study looks valid, because the article's title says, I think, a statistical valid statement. And it says, prolonged television viewing linked to increased risk. In other words, correlated with. As one goes up, the other goes up. As one goes up, the other. So correlated with, implied by the title. Down here, the author says, cutting back on TV watching can significantly reduce risk. If I change the word can to might, I'd be happy with that statement.
And significantly.
Well, good. And I'll let him even have significantly if you change the word can to the word might.
Yeah.
Because what does this imply? That one's causing the other. Yeah. The article's title implies a correlation between the two. This statement implies a causality. That's a very different thing. That's a very, very, very different thing. Extraordinarily different thing. So anyway, file that away. File that in the back of your mind.
And besides the graphs, actually, which you asked us to do,
oh, no,
they did not show. I mean, like, significant.
Totally. But the point is, even if they did, showing that there's a correlation versus a causation is a whole different argument. Then we'll get that at 244. Get that at 244. Cool? Make sense? Good. We'll shut this down for a little bit here. Okay, good stuff. Let's fire some light up for the time being. So, what I want to start today, and this will take us through Wednesday. We're not going to finish this today. I don't want to finish this today for a number of reasons. Actually, for two reasons. Number one, I don't want to finish it. Number two, I want you to have time to work on your project for Wednesday, in case you haven't got a chance to look at it yet. So, what I want to do is I want to start fusing this beautiful world of statistics that we've been in and marry it to the idea of probability. I want to start putting these things together. The reason you guys had the first two projects you had is because simply most textbooks, yours included, as skinny as this textbook is and as affordable as we were able to make it by chopping stuff out, I'm pretty stoked about that, it still has what I consider to be an antiquated introduction to probability, making you guys do lots and lots and lots of individual skill kind of mathy idea-based probability. Whereas the first couple projects you guys did, I immediately immersed you guys into data sets. That was the whole point, was here's data sets. What can we glean from these data sets? But I still want to come back. To this idea of probability. I think we've got, I'm going to put a check here tentatively, because I think we've got a pretty strong idea of what's going on over in that world. And we're not going to leave it behind. It's not like it's going anywhere. It's still going to be there. but I want to come and bring probability kind of to the forefront now. We've had enough time to kind of play with it in projects, and like I said, you'll play with it again for Wednesday and bring an even fresher view on Wednesday. But today what I want to do is I want to collect some data and kind of play with the idea of data collection. And what I really want to do is I want to start by talking about probability. I had you guys last time flip some coins, and unfortunately lost all that data. I think you guys may have it written down, but rather than reuse that data, we'll generate some new data today. I want to start with a simple question, and it's a fairly silly question because it involves a gambling unit. But if you roll a die once, okay, one die rolled one time, what's the chance or the probability? See, make sure this is okay if I use this notation. What's the probability that you get a 3? What is the chance if you roll a die one time, just one time? What's the chance that you get a 3? Jenny's got to vote for
1 out of 6.
1 out of 6. Do I have a second on 1 out of 6? We've got a second. All in favor? Aye. Any opposed? Do we need to discuss this any further? Hell yeah, we do. Yes, we do quite a bit. Now, Jaden, let's come back to this idea of 1 out of 6. Is it okay if I write it like that? Could you write it? No. How else can we write it, Jordan? Jordan, I'm with you. I'm with you. How else can we write it? Percentages are very, very good. Huh? We could call this, what would that be, 16.7%-ish? I'll put approximately. Or you go 17% if you want to. That's fine, too. 17%. Oh, okay, good. 1:6, that's totally fine. I tend to shy away. I'm kind of with Jordan on this one. And actually, even to kind of mutate it even more, it's very often in this class nice to use decimal representations of the percentages because those we can actually work with. And you'll see what I'm talking about as you slug through project number 2 for tomorrow, if you haven't already got a chance to look at it. In your first project, you would stop right here, essentially. Like we talked about things like the statistical likelihood of getting eczema, of your offspring getting eczema if both parents have either eczema or seasonal allergies and things like that. And you were kind of done. One kid, done. 3 in 10, 7 in 10, whatever the number was, I've forgotten now. With this project, this next project is called joint probability, which is when you have more than one thing. Suppose you have 3 kids or 4 kids. What's the chance at least one of them is going to have eczema or seasonal allergies? So then you're going to start doing math on these things. And it generally, looking at these 4 representations of probability, this is the easiest one to do math on. Followed pretty closely by this one. These 2 are the hardest to actually do mathematics on, because in order to do math on a percentage, you have to change it to a decimal anyway. But, hey, we're surrounded by the percentage symbol, Jordan, so I'm with you. I'm totally with you on that one. And this notation is also fantastic. It's absolutely fantastic. The trick with it is you have to do a conversion to get it into a usable form, mathematically. Hey, but for understanding, they're all valid. They're totally, but you can do it in words, 1 out of 6, and so forth and so on.
Like when I think probability, I just think the colon.
Totally fine.
So if we're going to do like math with it, then I don't like
That's totally fine. And that's why I tend to default to this one only because my brain has very little RAM. The older I get, the less RAM I have, which means I can't occupy it with a bunch of stuff. You guys are all young, it's awesome. You have plenty of RAM floating around. Me, not so much anymore. My RAM is corroded that I have. So the few pieces that I have left to keep as few things in them as I possibly can. Now, as Jada pointed out correctly, we are not done talking about this because I don't know what the hell that means. I want to know what that means. What does it mean to say, if I throw a 3-sided die one time, I have a 1 in 6 chance. Excuse me, a 6-sided die one time, I have a 1 in 6 chance of rolling a 3. Sorry, I was thinking 2. See, RAM, faulty RAM right here.
So that's exactly what it will do.
If we have a 6-sided die, there's a 1 in 6 chance of rolling a 3. What does that mean, friends?
There's only one side that has a 3.
Okay, how about the 6 on the bottom?
Then there's 6 altogether.
Okay, so what Haley's saying is, I'm going to take this fraction, and this is one of the reasons I love the fractional write-up, is because we can actually break up both pieces and kind of keep them like this. The idea is there is one side that contains a 3, and there are 6 sides altogether. Altogether. And I'll put it in parentheses. 1, 2, ... up to 6. in case you're unfamiliar. Basically what a die is a six-sided coin, essentially. A coin has two sides, a die has six. So, okay. Good.
So if we take, for example, if we took one chance, 5 more left.
Say that again, Elena, say that again.
Okay, so if we take, for example, we roll it once.
Yes.
But if we have 6 sides, it means we could have 6 chances.
To do what?
To get the 3
Okay.
out of these
We're going to
dice.
pause this bad boy right now. I'm going to give every one of you a die, and I want every one of you to roll it exactly 6 times. I love this idea right. Did you hear what she said? She said if you roll the die the first time, you might get a 3. But if you don't, you got 5 more shots.
Yes.
Let's test that right now. This is freaking